All right, so section 5.3, we were talking about graphs of radical functions. And then hopefully you guys were able to graph some of those in your assignment. The second part of the assignment, we're going to write the functions. So the first one says, let the graph of G be a horizontal shrink by a factor of 1/6, followed by a translation 3 units to the left of the graph of f of x equals cube root 2x. And we're going to write the rule for G. So it's been a while since we did this. Just copy down my question there. We need to do 2 transformations, and we need to follow the order. If you go out of order, you might get it right, but you probably will get it wrong. So the first thing is a horizontal shrink by a factor of 1/6. So that's our first transformation. Horizontal shrink now it says it in the problem. I'm writing it down because that's what I did in the answer key, just so you can kind of follow when you see my answers. But literally, I just copy down what it says right above it. So horizontal shrink by, it's not 1/2, it's 1/6. Sorry. Horizontal shrink by a factor of 1/6. So everything horizontal goes on the inside. And we're going to replace the x. We're going to replace the x. That's what we're going to do, is we're going to replace the x when it's horizontal. Replace the x. So my next step is going to look like cube root 2, but I'm not going to have x there. I'm going to have something else. So I'm going to put it in parentheses like that. So this is saying we're doing a shrink of 1/6. Because horizontal is always opposite, what number is going to go in the question, into the problem? Out loud. 6. Now it won't just be 6. No. It won't just be 6. It will be 6x. Because we're going to replace the x with another x. It's just going to have stuff with it. So do you see how I'm using my color to show you that the only thing I did was take the x out and replace the x? That's all I did. So now I'm going to simplify that, and I will have cube root 12x. Then there's a second part. It says followed by a translation 3 units to the left. Translate 3 units left. So we're going to replace the x because it's horizontal. Because it's horizontal, we're going to replace the x. So my next equation will say cube root 12. And then I'm going to replace the x. You see how the only thing that I'm changing is the x. The 12 is still there. What goes in this parenthesis is going to tell me 3 units left. So how do I do 3 units left? Amar? X plus 3, yes. So that goes in there. So then the last thing we do is simplify. And to simplify this, I will distribute it. So my final answer will be g of x equals, and distribute that, and I get cube root 12x plus 36. So when I did this in the answer keys, I wrote down what I was doing in a color, and then I did that thing in the same color so you can follow to see if you're making any mistakes. So here's another equation, and we're just going to use the exact same horizontal shrink, translate 3 units. We're going to use the exact same thing, but it's just a different question. So the first thing that we're going to do is horizontal shrink, factor of 1/6, Hanero. Are you writing? You have your stylus? Can get paper. So I'm going to have cube root, and I'm going to replace the x with 6x, and then minus 2. So all I did was replace the x. So I have cube root 6x minus 2. So I'm going to translate 3 units left. So I have cube root 6. I'm going to replace the x with x plus 3 minus 2. And then I'll distribute that 6, and I'll get cube root 6x plus 18 minus 2. Why did nothing happen to that minus 2? Why is it still minus 2 the whole time? Why did nothing change? Warren, do you know why? Because it's outside, and what kind of things did we do? Like, what kind of transformations did we do? Right, and horizontal are all on the inside. Okay, how about let the graph of G be a horizontal stretch by a factor of 3, followed by a translation 6 units to the right of the graph of f of x equals cube root x plus 3. Write a rule for G. I want you guys to try that one on your own. Try it. Good. If you got it right, then try the next one. I'm looking around. We're just to say here, and we did two of them together. No, I'm talking about the work that we've already done. We did it right. What are you going to go off of to help you this one? No, I'm not asking you to do that. We've already done this. We've already done these two. My question is, why didn't you write it even now? Because now you get to do this one directly. If you do that one on your own, then you don't want to do that. I'm going to go over this one and she writes this down. What is that? You're trying to do it ahead instead of taking the steps. Yeah, we're on side round. You're going to have to because we have to replace the X. Replace the X-Intercept. Okay, so a few of you did not follow my two-step process, but you got it wrong. So I would highly suggest, I mean, I've been teaching Algebra 2 for like, I don't know, 20 years. I would suggest doing it this way. I probably could do it in my head, but it would take me so much longer to do it in my head than it would be to do two steps. So I prefer to just get it right and not do it in my head. Now, writing out the words horizontal stretch by factor 3, that's up to you. I mean, that's written right above, so I don't care if you write that. I'm really doing that to help you guys so you know why I'm about to put a 1/3 x instead of x. I'm replacing the x with 1/3 of x. So I'm replacing the x with 1/3 of x. So when I replace that x, it still has to have an x there. You just can't get rid of the x. It's just a part of x. Okay, and then the second part, and then that is simplified. The parenthesis doesn't do anything for that one. Okay, so the second part, translate 6 units right. Oh, pictures today. I forgot about that. So that's going to keep it happening, interrupting. All right, so now we're going to replace the x because this is a horizontal translation. We're going to replace the x. And we're going to do that with, and it has to have an x in it. This is a translation 6 units to the right. So we're going to minus 6. To go to the right, we minus 6. So I'm going to replace this with an x minus 6. So I'll have 1/3 x minus 2 plus 3 So g of x is the cube root of 1/3 x plus 1. Any questions? Okay, and then I asked you to try the next one. If you haven't tried the next one yet, try it, try it, try it. So we haven't practiced this yet today. Vertical stretch. So we're not doing horizontal. And then followed by a translation 3 units up. So again, these are vertical. So vertical goes on the outside. The way that I can show that with my work, let's see, we've got a vertical stretch by a factor of 2. I'm going to put that 2. And I'm going to put a big old parenthesis. And I'm going to have cube root x minus 2. So I'm putting that 2 on the outside of the function. It's on the outside. The other one went on the inside. This one's going on the outside. Then I'll simplify what I have. I'm going to distribute that 2 cube root x minus 4. Then we have a translate 3 units up. Again, translation 3 units up is vertical. So I'm going to have a plus 3 on the outside of the previous function. I'm going to put that plus 3 on the outside. 2 cube root x minus 4. And that entire thing is plus 3. Let's simplify that. Get 2 cube root x minus 1. You see how vertical, we're putting them on the outside. So you put those parentheses in and you stay on the outside of the whole function before you simplify. So if you tried to do those questions in your assignment yesterday and then you were like, I don't remember this, we didn't do it in our notes. We have done it. It's not new. It's just been a month or so. So definitely wanted to take some time to go over that. So if you didn't do well on that or you didn't even do that yet, you should be good to go on that part of your assignment. And then this is the last part of 5.3 we didn't get to last class. Graphing parabolas and circles. We're going to graph these using a graphing calculator. So those of you that don't have a graphing calculator today or your batteries don't work, make sure you take good notes so that when you get batteries at home or you grab your calculator off your desk at home, you can practice it. But I am making a video, so you could also just go to this part in the video if you forget. It says using a graphing calculator, we're going to graph 1/2 y squared x, or 1/2, I can't read, 1/2 y squared equals x. We're going to identify the vertex and the direction that the parabola opens. Okay, so the equation is 1/2 y squared equals x. We're going to type that into our graphing calculator. So I'm going to go to y equals, and I got a lot of stuff in there. I got to clear some things here. That's from my pre-calc class. Okay, how do I type in 1/2 y squared? equals X? Nina? You don't know? You don't know? Ryan, you doing this with us? Are you on Y squared? Or Y? Are you on Y equals? I said it wrong. Sorry, Y equals. Who's my graphing calculator pros? Ma, are you a big graphing calculator guy? No? Ella? Well, what's wrong? Why are you guys all shaking your heads? Like, what's wrong? Tell me what's wrong. Why are you thinking you don't know how to do it? Nina, what's wrong? I can't hear you, hon. Correct. This graphing calculator is always set up to be Y equals. So if an equation is given to us and it's not Y equals, we have to make it Y equals. So we can't just go straight and plug it in. We have to know more than the calculator knows. So we're going to take this equation and we're going to solve it for Y. It's our first step. We're going to solve it for Y equals. So let's see. Multiply both sides by 2. And I get Y squared equals 2X. And then how do I get Y equals? Right now it says Y squared. How do we get Y equals? Ashlyn, how do I get Y equals? I am going to square root. Oh, yeah.
At this time, with SHS, please report to the auxiliary NHS.
Okay, so I'm going to square root, but there is a rule that when I physically put those square roots in, when it's an even root, I also have to put plus minus. Remember that rule? That rule exists always. So I have Y equals plus minus square root 2X. So when you have Y equals, how are we going to type that into our calculator? Type it in your calculator. Y equals. Does anybody need help typing this in their calculator? You need help, Amar? What do you need help with? The equals part. There's already the Y equals right here. Y1 equals. Who needs help typing this in their calculator? Genero. Head up. Sophie. Oh, you don't have a calculator. I forgot. Ari, do you have a calculator? Did you get it typed in? You did? How'd you type it in? Okay. So she knows what's going on. You cannot put this in as one equation. I was hoping somebody was going to ask where the plus minus button is. You guys are too smart for me. So you actually have to put this in as two separate equations. It is going to be one equation, but we have to put it in as two separate equations into our calculator. So we can do a square root 2x, and then we'll do a negative square root 2x. So we'll do both. Square root 2x, negative square root 2x. Make sure you hit negative and not subtraction, or it does not like it. Now, since mine is color, you can see the two different graphs, but just imagine, and I can change the color if I want, but just imagine it is one graph. That is a parabola. Where is the vertex of this parabola? Ella, do you remember what the vertex is? It is at 0, 0, yes. That point right there that has no mirror points. It's that one right at the center, 0, 0. And then direction of opening. Now, we definitely did not go over any parabolas this year that opened left or right, but they can open left or right. So this one opens to the Ryan. Thank you. Right. Okay. How about graphing a circle? We're going to graph x squared plus y squared equals 16. And oh my gosh, before we graph that, I need to go over something totally important. Off topic, but not off topic. I'm just go up here to the side. Is anybody double blocking right now in geometry? Yeah, you are. Okay. Hopefully you know this. If not, sorry. But there is this one thing that you guys learn. And you really should learn it before geometry, so maybe you already know it. There's like a right triangle with an A and a B and a C. And there's this theorem that connects the two sides with the hypotenuse of a right triangle. Does anybody know what I'm talking about? You know what I'm talking about, Tessa? Do you remember that theorem, what it's called by any chance? No? Jacob, do you remember what it's called? Pythagorean theorem, yep. Mm-hmm. And, man, I use this theorem all the time in pre-calc. All the time in pre-calc, like so much. So it's a pretty important theorem. Used for way further than just what we're looking at here. But the theorem is a squared plus b squared equals c squared. Now, here's a real test to see how good your geometry teacher was last year. Okay. There are integers. There are numbers that can fit in A, B, and C. They're called triples, and they're ones that you should kind of memorize that always fit in there. There's some famous ones. There's some ones that you should definitely memorize. Does anybody remember any of those triples? Come on, Sophie. No. Okay. One of them does have 8. It's like 8, 15, and 17. That's a triple. That's not the most remembered one. So good. She got one of the numbers. Does one of them have 1? No. Does one of them have 2? No. Do you remember? Do you know one?
I think 3, 4, 5.
3, 4, 5. That's like the one that most people will remember. Right. So if I have 3, 4, 5, that will always make a right triangle. That's the one that most people remember, the triple 3, 4, 5. Gosh, where am I going with this? If I were to take this equation using the Pythagorean theorem, if I were to actually, multiply and add or square it and add it, I would get 9 plus 16 equals 25. And 9 plus 16 does equal 25, doesn't it? So here is where people make mistakes. Can this work? Does 3 plus 4 equal 5? It only works after you square the number. So you cannot square root an entire side that has squares on it, but a plus sign in between. You can't do that. I want you to see with real numbers here that this does not work. Okay, now let's move on to what we're doing. Why is she doing all that? We've got x squared plus y squared equals 16, and we're going to solve for y so we can plug it in our calculator. This is an equation of a circle. So I'm going to take away x squared from both sides. Now, if you want to write negative x squared plus 16, that's totally fine. I'm just being lazy. I'm sticking it on the end. What do I do now to get y by itself? What do I do now to get y by itself? Square root both sides. And if I square root, I also have to put the plus minus. So get y equals plus minus square root 16 minus x squared. What do I do now? Ashley? That is a very good question. If I had something where it's squared on both sides and there is a plus or minus sign in between, did that work with the Pythagorean theorem? So will that work for me to take the square root of 16 here? It will not work. You will not get the right answer. You cannot do that. What's my goal? What am I trying to do? What was my goal? It's written right here. Solve for y. Did I solve for y? So what do I need to do? Just plug it in your calculator. Like, you do not need to worry about trying to simplify anything, because that was not our goal. Our goal was just get y equals. So let's go to our calculator and we're going to type in y1. And we'll just do square root 16 minus x squared, y2, negative square root 16 minus x squared. So that's what we're going to type in our calculator. Now, when you graph this on your calculators are a rectangular screen. Like, they are wider than they are tall, but we are counting by tens. So it's actually stretched. It's not going to look like a circle. We can change our window. And I think it is, I'm trying to remember now. I think it is, I think it's -6 to 6 and then -8 to 8. I think that's the right one. I haven't done this for a while. Nope, that was the wrong direction. I think I have them reversed. It's -8 for the x's and then the 6 for the y's. There's another way I can do this. There we go. It looks better. It looks better. There's also a zoom. And then I think it's square 5, zoom 5. Will make it look like a good circle if you want it to be square. You see how the ends don't meet all the way? They do. It's just the pixels on the calculator are really fat and it couldn't graph it accurately, so it just doesn't have the pixels there. But they do connect. We know it's what it's supposed to look like, then we're good. Okay, so that's how you graph circles and parabolas that open to the side. We have to identify the radius and the intercepts of this circle. So looking at your circle, the radius would be from the center to any point on the circle at all. How far? Jackson, what's the radius?
At this time, with SGA
Say it one more time, Sonny. Oh, I'm not going by tens. That's just counting normal. So 4, yeah. So our radius equals 4. And then the intercepts. So they're talking about the X-intercepts and the Y-intercepts. How about we list our X-intercepts first? And then we'll do our Y-intercepts second. Holland, can you tell me the X-intercepts? I heard -4. That's all I heard. Oh, 4 and -4. Yeah. So I'm going to write those as ordered pairs. So we'll say -4, 0, and then 4, 0. Ugh, it's messy. -4, 0, and 4, 0. I wrote those from left to right. And then our Y-intercepts. Aya, can you tell me the Y-intercepts, please? A little bit louder, hun. 4 and -4, yeah. And again, I'm going to write those as ordered pairs. So I'll write -4. Nope, that's not how we write them. 0, -4. 0, 4. So that is how you finish the rest of that first assignment. I'm going to go ahead and stop this video, and then we will open our other set of notes.